Chapter 6, Section 2 is about solving systems of equations using substitution. In Section 1 of this chapter, we were solving systems of equations using graphing. So this is another method that we can use to help us solve systems of equations that does not require us to graph, because graphing is not always going to be the best way to solve a system of equations. When we were in Chapter 1, I was picking certain equations to give you guys for a reason. That way, when you graph them on the coordinate plane, they would intersect at a really nice point. But if I gave you just any two random equations that I thought up of, I can't necessarily guarantee that that would always be the case, that it would work out that way. So we have other methods that we're going to get into now that allow us to still solve these systems of equations, but be able to open up the door for if you don't necessarily get a perfect point, if you get a decimal or a fraction or something like that for a coordinate, which those would be a lot harder to find on the graph because you'd have to be kind of estimating or guessing where you think it is. So today we're going to get into substitution. I want to first just go through what are the steps that you follow when you're using substitution. The first thing that you're going to want to do is look at your two equations and solve one of the equations for a variable. Now it does not matter which variable you choose to solve for. So if you want to solve for x because you think that's going to be easier, then solve for x. Same could be said for y. If it looks like it's going to be easier to get y by itself, then solve for the y instead. Once you have that done, the second step is to plug the value for the variable into the second equation. So after you have rewritten one of your equations, then you're going to want to take that and plug it into the next one, into that second equation. Then what you're going to do for step 3 is solve the second equation. So at this point, you'll only have a new equation that has one variable in it. So you're getting rid of the double variables that we're running into the issues with. You'll have a new equation that just has only x or only y, and then you're going to solve for that letter. Once you've got x or y solved for, then you're going to take that value and plug it back in to one of the equations that you started with at the very beginning. Then you'll solve for that next variable that you're missing. And then you should be able to check your answer and see if you did it right. So I'm going to go over this first example with you here. I've got these two equations, x plus y equals 16 and 7x plus 5y equals 90. So the first thing that I want to do is solve for one of my variables up here. Now it doesn't matter which one I solve for. I'm just going to take a look at this top equation, this x plus y equals 16. I think that that's going to be easy to get either x or y by itself. It really doesn't matter which variable you solve for, but let's just say we want to solve for y. So you're kind of still maybe thinking about what you did last section. To do that, I'm going to subtract the x. And so now that's going to say, I'm going to write it over here, y equals negative x plus 16. So you've taken care of step 1. You've solved one of your equations for one of your variables. We've solved this equation for y. Now what I'm going to do is take this portion. So I'm now saying that y is the same thing as this negative x plus 16. So I'm going to take this and plug it in for y in the second equation, the equation that I haven't dealt with yet. So instead of it saying 7x plus 5y, it's going to say 7x plus 5, and instead of y, I'm going to put in that negative x plus 16. And I put that in parentheses next to the 5, because I'm going to have to make sure that I take 5 times both of those pieces, and then set this equal to 90. So we've solved for one of the variables. Now we're plugging it back into the second equation. Now we're going to solve for x. If you guys notice now in this equation, I only have x's. I got rid of the x, y that I was seeing up above. So now I have one letter to solve for. What I need to do here first is distribute the 5. So that says 7x, and then 5 times negative x would be negative 5x. 5 times 16 would be 80, and that's equal to 90. I can combine the 7x minus 5x, that would be 2x, and then plus 80 equals 90. I'm going to subtract 80. So I have 2x equals 10. Then I divide by 2, and I get x equals 5. Now, you just solved for one of your variables. Now we need to go back and solve for y. So step 4 is to take your answer that you just found. So I just found x to be 5. And you plug that back into one of these two equations up here at the top. It does not matter which one you go back into. I would just pick the one that you think is maybe going to be easiest. So for me, I think that top one is probably simpler. So I'm going to, instead of putting x plus y, I'm going to do 5 plus y and set that equal to 16. Now to solve that, I'm going to subtract the 5. And so I get y equals 11. Okay, so there's your solution, 11 and 5. So as a coordinate, just like when we were graphing, we would write that as x first, so 5 first, comma, then your y, 11. So this would be the solution. This is where those two lines would have crossed on the coordinate plane if I was graphing them, but I'm not doing graphing right now. The last step that I had up above when I went through those was checking your answer. So if I look back at that equation that I've got highlighted up there, if I plug in 5 for x and 11 for y, and I do this math here, I do get 16 equals 16, so it checks out. That's an easy way for you guys to check and make sure that you got the right answer. So in the future, when you're taking an accountability check, when you're doing a test, and you're maybe having some extra time before you hand in, go back and check your work. Go back and plug those numbers into your equation and see if you get it to balance out. Because if you do, that's a really good way for you to understand that you got it right, that you did everything correct. If it didn't balance out, that would mean that you maybe need to go back and relook at what you did because you probably messed up somewhere, and it could be something minor or it could be something a little bit bigger. And then that gives you that opportunity to go back and fix your mistake and then maybe get those points back that you would have missed had you just handed it in early. So I want you guys to take a look at this next problem here. I want you to pause the video here, take a couple minutes to do this problem, and then come back and see how I solved it. Okay, so what I did first on this one is I rewrote that top equation. So right now it says y minus 1 equals 5x. What I did is add the 1 over, so that it says y equals 5x plus 1. Then for my second step is I plugged that 5x plus 1 in for the y in the second equation. So it says now 4x, and instead of y, so instead of plus y, it says plus 5x plus 1 equals 10. Then I combine, so 4x plus 5x is 9x. Plus 1 equals 10. So like this is really getting into step 3 because I'm solving for x now. I subtract 1. So I got 9x equals 9. Then I divided by 9, and I got x equals 1. So there's part of my answer. Then, if I'm still following my steps from up above, step 4 is to take that 1 and plug it back into one of these up here. Doesn't matter which one. I'm just going to go ahead and use that top equation because I think it looks a little bit simpler. So I'm going to take y minus 1 and set that equal to 5 times 1 because I said x was equal to 1. So this is y minus 1 equals 5. I'm going to add 1, and I get y equals 6. And that right there is really step number 5, solving it. So my answer here is going to be 1, 6. That's my solution. Again, if you wanted to check your work, I would go back in maybe to that still top equation there. We would have 6 minus 1, because we said y was 6, equals 5 times 1. And I get 5 equals 5. So it does check out. Now, when we were graphing, we did talk about those special scenarios. You know, when we had parallel lines, that meant that there was no solution. If we had the same line, that meant that there was infinite solutions. You're still going to run into those kinds of cases. So looking at the equations, again, might be able to tell you a lot about what type of lines you're dealing with so that you kind of know before you even get too far into the process, what type of solution are you going to end up with? Are you going to get a coordinate like we just saw in those last two examples, or are you going to have one of these special cases where you're going to have no solution or infinite solutions? When I take a look at these two equations here, y equals 3x plus 4 and y equals 3x minus 3, I'm noticing right away that they both have 3x. That means that they have the same slope. And if you remember, same slope lines means that they're parallel. Parallel lines means that they're never going to cross, so you'll never be able to find a solution. Really what's going to happen if I were to try to solve this using substitution, they're both already solved for y. So I could take that 3x plus 4 and replace it for that y underneath it in that second equation. So it would look like this, 3x plus 4 equals that 3x minus 3. Now when I do that, if I try to start solving and try to combine my 3x's together, these are going to eliminate each other out, and I'm going to be left with 4 equal to negative 3, which is not true. 4 and negative 3 are not the same. So this is considered an inconsistent solution, which we saw in section 1, meant that there is no solution because those lines are never going to meet. Again, like I kind of pointed out above there, they had the same slope. But different y-intercepts. Their b values are different in their equations, which again just kind of helps solidify that argument that these are parallel lines, so they're never going to cross each other. They're always going to be sitting side by side, never crossing. Now, if we take a look at this next example here, this is another special case that we're going to run into. So we've got 2y equals 6x plus 4, and we've got y equals 3x plus 2. What they did here is they saw that on that second equation, y was already solved for. So they took that 3x plus 2, and they plugged it in for y on the top equation. So they rewrote that as 2 times that quantity 3x plus 2, and then that's setting equal to 6x plus 4. Now to simplify this, they would have used the distributive property on the left-hand side. And if you look here, it says 6x plus 4 equals 6x plus 4. They're identical. Every single parts, all the parts of them are equal to each other. So these are equal expressions, which means that they're the same line. So these would have identical like points. All the points would be the same. So this would be an infinite solutions situation where you're going to have an unlimited amount of answers for this problem. Another thing to maybe just take note of, that first equation, if we had divided everything by 2 to get that y by itself, you would have y equals 3x plus 2, which is the exact same equation as we had right underneath it. So that would be something else that maybe some of you would have noticed if you had tried to simplify that a little bit more, that you would actually end up with the exact same equation. And if you see that, then you automatically know that it's going to be infinite solutions. So on the next page here, there are 2 practice problems. There's this one, and then there's this one here underneath it. I want you to give these a try on your own, both of them. So you're going to need some time to do that, so you need to pause the video here, try to work through both of those practice problems, and then come back and watch what I did with them so you can see what the solution should have been. So what I did is I took that first equation, x minus 4y equals 3. I added 4y over so that it said x equals 3 plus 4y, or you could have said 4y plus 3. It really doesn't matter. Then I took this expression, 3 plus 4y, and I plugged that in for the x in that second equation. So it says 2 times 3 plus 4y, and then minus 6 equals 8y. Then I distribute it here, and so I have 6 plus 8y minus 6 equals 8y. Over here on the left-hand side, I see 6 and minus 6. So those are gone. So I was left with 8y equals 8y. Right there, I see that they're the same. They're matching. This is a true statement. So I went ahead and just wrote down that this is the same line, which means that this would have infinite solutions. Now, for the second practice problem, I took that top equation that says 2x minus y equals 0. First thing I did is I added y. And so it says 2x equals y, which is the same thing if I flip it around and I say y equals 2x. The reason why I switch it around is so that I can see I solved it for y. So I'm going to take that 2x here, and in the second equation, I'm going to plug it in for the y. So it's going to say 2x minus, instead of y, I'm going to put in 2x, and that's going to equal negative 2. Well, 2x minus 2x is 0. So I'm trying to say that 0 is equal to negative 2, which is not true. So these would be parallel lines. Which means no solution. For this last example here, we've got a word problem. So we need to read through it, be able to write out our two equations here, and then use substitution to solve it. So it says that two angles are supplementary, which means that they add up to 180 degrees. One angle is 8 degrees less than 3 times the other. What is the measure of the two angles? So I'm going to use x and y to represent my two angles. Now I know that they are supplementary, which means that when I add them together, they should equal 180 degrees. Now one of the angles, so let's just say x is 8 degrees less than, so that means that we're going to be subtracting 8 from 3 times the other. So the other angle would be your y. So you're doing 3 times the other angle, so 3 times y, and you're subtracting 8 from that. Now to use substitution, I already have this equation solved for x. So I'm going to take this 3y minus 8, and I'm going to plug it in for the x in that first equation. So that's now going to say 3y minus 8 plus y equals 180. So what I'm going to do here is I'm going to add this 8 over because I need my numbers to be together. So that's going to be 188. The other thing that I can do is I see a 3y and I see a y. So I'm going to go ahead and combine those and write 4y. Then I'm going to divide by 4 on both sides. So y is going to come out to be 47. So there's one of your angles. So now what I can do to find the other one is go back up into one of my original equations here and solve for the other letter. So I'm just going to use that top one, x plus 47, because that's what we said y was, equals 180. I'm going to subtract 47. And so that should come out to be 133. So x is 133, y is 47. If I wanted to check my work, all I need to do is add those two together. And they should equal 180 degrees, which they do when I add them. So that means that I did it right because it checks out.